Welcome to the DIY Honda Garage channel. The purpose of this presentation is to provide a detailed troubleshooting guide for DTC P006E, known as the Turbocharger power supply circuit malfunction, specifically relevant to the Honda Civic models from 2016 to 2021. This diagnostic trouble code indicates an issue with the electrical supply to the turbocharger, which plays a critical role in enhancing engine performance by forcing more air into the combustion chamber. The turbocharger is responsible for providing boosted power and improving fuel efficiency. When there's a malfunction in the power supply circuit, it inhibits the turbocharger's operation, potentially leading to performance issues such as reduced acceleration and increased emissions. Understanding this code is essential for ensuring the vehicle operates smoothly and efficiently. DTC P006E indicates a malfunction in the turbocharger power supply circuit. The primary component affected is the turbocharger itself, which is crucial for engine performance, especially in turbocharged Honda Civics. This error directly points to a power supply issue that disrupts the control module signals to the turbocharger. The turbocharger is generally located within the engine compartment, specifically connected to both the exhaust and intake systems. Additionally, the relays and fuses controlling power to the turbocharger may be housed within an under-the-hood relay box. A malfunction in this circuit can result in either the turbocharger not receiving the necessary voltage or current, leading to potential performance degradation. Several factors can cause DTC P006E. Firstly, poor electrical connections, including loose terminals or corroded wires, can disrupt the power supply to the turbocharger. Inspecting these connections is crucial to ensure they provide a solid electrical path. Secondly, a blown fuse, specifically the A27 fuse, located in the under-hood fuse relay box, can interrupt power flow necessary for proper turbo operation. A blown fuse will prevent the electrical circuit from completing, thereby inducing this error. Additionally, a failure in the powertrain control module, PCM, or the relay circuit board can contribute to this issue, as these components manage and supply the electrical signals needed for turbocharger function. When DTC P006E is triggered, several symptoms may manifest. One of the most notable signs is reduced engine performance. The vehicle may fail to accelerate as expected due to insufficient turbo assist. Drivers might also notice the illumination of the check engine light on the dashboard. In certain situations, additional warnings specific to turbocharger functionality may also appear. These symptoms can result in a significantly compromised driving experience, emphasizing the importance of addressing the underlying issue promptly to restore normal vehicle operations. Moreover, if the turbocharger is not functioning, overall fuel efficiency can decline, further highlighting performance degradation. The first step in troubleshooting DTC P006E involves initializing the vehicle's ignition to the on mode. This is necessary to power up the vehicle's onboard diagnostic system and allow for communication with the Honda Diagnostic System, HDS. Next, it's essential to clear any existing DTCs using the HDS. This ensures that the system is reset and only current, relevant codes are monitored. Once cleared, the technician must check for any confirmed or pending DTCs. If DTC P006E is present, the diagnostic process can continue with further troubleshooting steps. If not, there may be an intermittent failure, and it is advisable to inspect for poor connections or loose terminals at the relay circuit board and the PCM. In troubleshooting step 2, the technician is required to check for any pending or confirmed DTCs using the HDS after the initial clearing. This step is crucial for ensuring that no additional issues are present that could affect the turbocharger's operation. Specifically, it is imperative to verify whether DTC P006E or P006E are indicated, as these pertain to the electronic throttle control system (ETCS) control relay malfunctions. If these DTCs appear, the technician should shift focus to their specific troubleshooting protocols. However, if no issues are indicated beyond P006E, then it is appropriate to advance to inspecting the fuses. The third step in the troubleshooting process necessitates turning the vehicle to the off position, allowing for a safe inspection of the electrical components. The technician should then check fuse A27, a 10-amp fuse located in the underhood fuse/relay box. This fuse plays a vital role in the power supply circuit for the turbocharger. If the fuse is intact, it indicates that power supply to this circuit is intact, and the troubleshooting can continue to the next steps. Conversely, if the fuse is found to be blown, this indicates a need for immediate replacement and could suggest potential issues with the wiring or connected components. In this step of troubleshooting, the technician will focus on checking for any open wires, specifically on the VB-ACT-Phi sub-relay outline. The process begins with jumping the SCS, short circuit simulator line, with the HDS and waiting for more than 1 minute to ensure accurate readings. After that, specific connectors must be disconnected: the PCM connector A and the relay circuit board connector C. The goal of this procedure is to check for continuity between designated test points when the vehicle is in off mode. These test points help establish whether the wiring connecting the relay circuit board and the PCM is functioning correctly. If continuity exists, it confirms the wire integrity, leading to further checks on the relay circuit board, or possibly substituting a known good PCM for further diagnostics. In this critical troubleshooting step, the focus shifts to identifying any shorted wires specifically on the VB-ACT line. The process begins by removing the blown fuse A27 from the underhood fuse relay box, which acts as an initial safety measure. After the fuse has been removed, the technician will jump the SCS line with the HDS again and wait for more than 1 minute. It is essential to disconnect the PCM connector A beforehand to ensure that continuity tests can yield accurate results. The next step focuses on verifying continuity between the PCM connector and body ground. If continuity is confirmed, it indicates a short in the VB-ACT wire, necessitating repairs. Replacing the blown fuse A27 will be necessary, and if it blows again, it may suggest a more extensive issue with the fuse relay box that requires replacement. Once repairs are complete, it is essential to perform a final verification of the repairs conducted. This involves rechecking the diagnostic trouble codes using the HDS to ascertain that DTC P006E no longer appears in the list of pending or confirmed codes. After confirming the absence of the code, it is crucial to ensure that the turbocharger is functioning normally as intended. Observing the behavior of the engine during acceleration and overall performance can indicate successful repairs. Lastly, customer satisfaction should be prioritized. Ensuring that the customer has a clear understanding of what led to the DTC and how it was resolved will enhance trust and confidence in the service provided. Regular feedback from customers can also provide insights for potential improvements. Preventive maintenance is a crucial aspect of vehicle ownership, especially regarding electrical components like the turbocharger supply circuit. One essential practice is to routinely inspect electrical connections for corrosion or looseness. This simple maintenance task can prevent multiple potential issues, including DTC P006E, from arising in the first place. Additionally, fuses such as the A27 should be routinely checked and replaced when they show signs of wear or failure. It is also advisable to keep the powertrain control module, PCM, updated with the latest software to ensure optimal communication and performance. Regular maintenance can extend the life of the turbocharger and other critical components, ensuring the continued efficiency and performance of the Honda Civic. In conclusion, understanding the nuances surrounding DTC P006E is vital for effective troubleshooting and repairs in a Honda Civic from 2016 to 2021. The turbocharger plays a significant role in enhancing engine performance, and any malfunction within its power supply circuit can drastically affect driving dynamics. Adhering to a structured diagnostic process is key to efficiently identifying the root cause. Whether it be poor connections, a blown fuse, or a failing PCM. Furthermore, regular maintenance can mitigate issues before they escalate into serious problems, making it an invaluable practice for vehicle owners. By maintaining a proactive approach, technicians and owners alike can prolong vehicle performance and reliability while keeping costs down. Please like and subscribe to the channel. See you next time.